So first one we'll do, I'm just going to do one question with you. You'll try one and then we'll do a couple questions from the homework. So we're just going to do substitution method first and then elimination second. So just like we did in 10C, guys, it's exactly how it sounds. Substitution, you're going to take one equation and substitute it into the other equation, right? So the thing is with this though, you do have no longer just two linears, right? Because with two linears, it didn't matter what you rearranged. If you rearranged for, if it was in terms of x and y, it didn't matter if you rearranged for x or y, right? It was your choice, which was easier. But when you're doing a system where it's a linear and quadratic, okay, you are going to, it's easier to take the linear and substitute into the quadratic. But guess what you're going to substitute in for? Right, you're going to have to substitute in for the y and put it in terms of x. Because then if you do that, you're going to have in this situation, you'll have a quadratic to solve. Do you guys see that? Picture that? Okay, so, and the top one is going to be nice to solve for y. Okay. And even if that y wasn't by itself, had a coefficient of 1 on it, you'd still, like I said, move it around. So you had y equals, put it into the other one. So if I rearrange this one, it looks like we have a 5x minus 10 equals y. So I move that around. So 5x minus 10 can go into the second equation where the y is. So this is going to be not obviously exactly the same as we did in 10C, but it's very similar, right? It's the same process. It's just in 10C, you always, once you did your substitution, ended up with a linear equation, right? Here, if we're doing a linear and quadratic, we're going to end up with quadratic equations. So away you go. So we have x squared plus x minus 2 times 5x minus 10. And guys, if I wanted to, could I rearrange the bottom one for y and substitute it into the top one? Yeah, it just would have been way messier, right? If you would have chose to do that, then you're substituting an x squared divided by 2 plus an x divided by 2, right, into where the y is. You're just creating a messier equation, but it would solve the same. So am I done? No. Right, so you know that we're finding, because we solved them graphically yesterday, right? So we're solving for x and y. So this looks like if you were to graph it, it's going to have 2 points of intersection, right? So we do need the outputs. So you can use either equation, but again, since you're using substitution just like we did last semester, you might as well use the equation that's already rearranged for you, right? Because we can use that one, because I know I always stress, guys, use the originals, use the originals. But in this situation, and even last semester, we use the originals to check. I can use the rearranged equation to get my output, because my check will find out if I rearrange something wrong, right? So use whichever equation's easier to get the output, and then check in your original. please make sure that when you guys are solving them that you put the pairs back together. Right? So make sure that I know that you know that 5 goes with 15 and that 4 goes with 10. So there's my solutions. X equals 5 when y equals 15, and x equals 4 when y equals 10 are my two solutions. And I guess I'll show another verification. But like I said, you won't get marks for this. This could just be done on your calculator. So go ahead, do the your turn. And then after the your turn, guys, you're just going to do a couple questions from the textbook, and then we'll come back together in about 15 minutes or so. So I'll put it down here because I know you guys are going to finish at different times. So when you're done that your turn, do page 451, number 3.